In this video, we're going to continue looking at examples on how to graph rational functions. We're particularly going to work with just this one function, f of x equals x squared minus 36 over x plus 6. Now, if I were to take a look at this function right off the bat, something in the numerator should stand out. X squared minus 36 is a difference of squares, which means the numerator is factorable. And so that's what I'm going to do first, is I'm going to take a look and see that the factored form of x squared minus 36 is x plus 6 times x minus 6. And then I have my x plus 6 in the denominator. Now this is the crucial part of the problem, and the reason why is right now I can see there is a common factor in the numerator and the denominator, and that is x plus 6. So we learned in the beginning of this concept that we can actually cross out common factors. However, we also learned when we're dealing with asymptotes that if you have a common factor in both the numerator and the denominator, and you cross it out, that creates a hole in the graph, a point of discontinuity. And so we're going to have a hole at the solution of this factor. And so x plus 6 equals 0. We're going to have a hole at x equals negative 6. And so that is the important part of the problem, is to make sure you factor the numerator, factor the denominator, if applicable, and if they have a common factor, you create a hole. And so we're going to go ahead and let's cross out this word vertical. And let's put POD for point of discontinuity, and that is at x equals negative 6. If we take a look, we need to figure out, is there a horizontal or is there a slant asymptote? And you could look at the degrees, but let's actually rewrite the function, because I have this originally, and then I factored it, and I crossed out. And I'm going to write down what remains. My function I have right now is f of x equals x minus 6. The x plus 6 factors canceled each other out, and so I'm just left with x minus 6, and that should stand out because, well, that's just linear. It isn't rational anymore, it's linear. So do I have to use the idea of checking my degrees for a horizontal or slant asymptote? And no, I don't, because linear functions have a common rate of change. So there is no horizontal and there is no slant asymptotes. So now we graph. To graph this, it's linear. So it's in slope-intercept form. I have a y-intercept at negative 6 for x minus 6. And I have a slope of 1. And as before, I can go up 1 over 1, down 1 over 1, but then I'm not extending across the entire grid. I have to keep that pattern. What I can do is I can go up 3 over 3, up 3 over 3. And I'm going to come back to this point right here. And I'm going to go up 3 over 3, up 3 over 3. That makes it so I can actually extend across the whole graph. And so down 3, left 3, and then down 3, left 3. So what I'm going to do is I'm going to go back to that one point, and that was here. I marked at 6. And I want to go back because I could also go up 6, right 6. I can go down 6, left 6. Now what should stand out in your mind is this part right here, is that there is a hole at x equals negative 6. So what that means is here's where x equals negative 6. I'm going to come down. This point I marked right here is actually a hole. It is not part of the graph. It cannot be part of the graph because it's where the denominator equals 0. And so what I'm going to do is at this x equals negative 6, I am going to put a hole. And we use an open circle for that. And then when you connect with your line, You just don't put the line through the hole. And so this is my graph. You see it's linear. However, at x equals -6, a value cannot exist. There's a point of discontinuity. So I mark at that point that we found using our slope a hole on the graph. And so as I mentioned at the beginning of this video, this example was different. This example dealt with the idea of finding a hole, finding a point of discontinuity. And the way you know that a rational function will have one is based off of, is there a common factor in the numerator and the denominator? Keyword is factor. So make sure your numerator is factored, your denominator is factored, and then check for the point of discontinuity.